Good afternoon, sir.
Okay. Can you see the screen? Screen appear?
Yes, sir.
Okay. Last time I gave you a
Recording in progress.
last time I gave you a problem on irrigation scheduling. And they are actually, first of all, I am recalling what we have done last time. Irrigation scheduling, the components of irrigation scheduling. Irrigation irrigation scheduling can irrigation salusum karanawa, jal sampadana paddhatiya salusum karanawa. Here, I discussed with you there are three components. Pradhana kodas tunak තියෙනවා. Number one, how much to be irrigated. How much to be irrigated mean? කොපමණ ප්‍රමාණයක් වතු දෙන යුතුද? The answer is crop water requirement. The second one, when to be irrigated. There, the answer is irrigation interval. The third one, that means if you apply water today, when you have to apply next. The third one, how to be irrigated. How? Therefore, the answer is the method of irrigation. Jal sampadana krama. These three components I explained last time. Introduction. Finally, I assign you a problem. I think you have gone through. But however, today I am going to discuss that first. Step by step I am going to explain. This was the problem I gave you. Give me 1 minute. This was the problem I gave you. Can you remember? There is a cropping field of chili. I gave you, last time we discussed soil moisture constants. Number one, field capacity. Field capacity. You may remember that is the maximum capacity of capillary. Capillary is and I told you that is the upper limit of irrigation. The second one, the moisture content and permanent yielding point. I discussed with you saturation, field capacity, temporary yielding point, permanent yielding point is there I discussed with you, permanent yielding point is the point where the capillary water is over, finished. Kesa Karsanjari Ivarunanam appear permanent yielding point here. Then what would happen? Plant may die. Plus merino, crops may die. Therefore, what I discussed with you, in the half, about half of the available water. Available water. Available water water available for plant uptake. That is in between maximum field capacity, minimum permanent yielding point. Uparima sesthadharitave avama sthira malumaki. Then the range field capacity minus permanent yielding point. Uparima saha. When make it up again, available water. We discuss. Then I discuss temporary yielding point. Normally, half of the capillary water is finished. Case එක ජලයෙන් 50% වෙච්චාම plants starts to build. ගස් මැරෙන්න පටන් ගන්නවා. That is to indicate the requirement of next irrigation. ඊළඟ ජල සම්පාදනය කරන්න කියලා කියන්නේ. එහෙමනම් what happened? We have to start from temporary melting point. Half of the capillary water. ඒකට අපි කියනවා allowable moisture deposition level. පේනවද? පස්වෙනි එක allowable moisture deposition level. ඉඩ දෙන තෙතමනේ පහළ යාමේ සීමාව. Then we discuss different soils are there. Loose soil, burul pasak, long soil like sandy soil like burul. Hard soil, thada pasak, clay. Then what else? Can you remember you draw yourself? ඔයාලම ඇඳා. Soil profile එක ඇඳන්නේ last time. Soil aggregates, micropores, macropores, 3 types of soil වල මේ ඔක්කොම ඇඳා. එතන මතක ඇති micropores, that is capillary water body. Then macropores, gravitational pore water. එමනම් what you should know, how much micropores is there? කොච්චර micropores volume එකක් තියෙනවද? How much volume micropores? That is the space for water, capillary water. ඒක දැනගන්න ඕනේ. ඒක පෙන්වන්නේ soil type එකෙන්. That is given by soil type that indicates bulk density. Bulk density. That is why bulk density is there. In a hard soil, bulk density is high. Matti pasaka, thada pasaka, bulk density is වැඩි. It can retain much water. In a sandy soil, bulk density is less. Then what happens? It is a loose soil. Then root zone depth, moola kalape ගැඹුර. You may remember I discussed with you. Only up to the root zone we supply water. moola kalape ගැඹුරට විතරයි අපි වතුර දාන්නේ. That is called, therefore, you should know what is the depth of root zone from soil surface. මතු පිට පොළවේ සිට මූල කලාපයේ කෙරවලට පල්ලෙහාට කොච්චර දුරක් තියෙනවද? In this example, that is 0.2 meters. In centimeters, 20 centimeters. Centimeter visa. Cropping area. Now we are going to schedule irrigation. Therefore, you should know the cropping area. ඔබ දැනගන්න ඕන කොච්චර වගාපින් ප්‍රමාණයක් තියෙනවද cropping area. In this problem, it has been given 0.4 hectares. මම එදා කතා කළා. 0.4 hectares කියන්නේ 0.4 hectares කියන්නේ 1 hectare කියන්නේ 1000 meters, sorry, 100 meters into 100 meters. Meter 100 දිග 100 පල්ල කොටුව. However, a square. When had only got තියෙන්න පුළුවන්. However, the area of a hectare is 1 hectare is 10,000 square meter. Why? 100 into 100. 100 දිග 100 පල්ල. එහෙනම් 100 වැඩි කිරීම 100 කියන්නේ 100 බිඳු 2යි. එහෙනම් 100 වැඩි කිරීම 100 කියන්නේ බිඳු 4යි. ඒ කියන්නේ කොච්චරද 10,000. 10,000. What is the area here? 0.4 hectares. And a 0.4 into 10,000 square meters, 4,000 square meters. Is it clear? Then I discussed last time irrigation application efficiency. Jala sampadana yedime karyakshamtava. Can you remember we discussed wastages in irrigation? Jala sampadane jale නාස්ති වීම wastages. එතෙන් දැන් අපි දෙකක් කතා කරනවා. Number 1, irrigation efficiency. Irrigation application efficiency. ජලයේදී මේ කාර්යක්ෂමතාවය. What is efficiency? What you return as a ratio of what you applied. ඔබ යොදපු කොටස ලැබිච්ච කොටස as a percentage. අපි කියනවා කාර්යක්ෂමතාවය. එහෙනම් මෙතන මොකද කියන්නේ? Irrigation efficiency 50%. 50% you can see here. That means what? If you only 50% water is absorbed to the crop. If you apply 100, ඔබ ජලයේ 100ක් දුන්නොත් 50යි ගහන්න ලැබෙන්නේ. then what happens rest 50? අනිත් 50 මොකද වෙන්නේ? wastage. හානි වෙනවා. Now, discharge rate of electrical centrifugal pump used for irrigation. Discharge rate, විසර්ජන වේගය. විසර්ජනය ජලය පිටත් වෙනවා. විසර්ජන වේගය. Electrical centrifugal pump, විද්‍යුත් කේන්ද්‍ර අපසාරි පම්පේ used for irrigation. Your home, my home, wherever. ඔබේ ගෙදර අපේ ගෙදර හැමතැනම තියෙන්නේ centrifugal water pump එක, electric pump එක. බොහෝ දෙනෙකුයි. විද්‍යුත් කේන්ද්‍රසාරි පම්ප එක. Then how much volume you can pump using that, or volume you can draw using that pump. කොච්චර වතුර ප්‍රමාණයක් දෙන්න පුළුවන් දේ පම්පේ. තප්පරයක. That is displayed in the pump. Pump එක පිටින් ගහලා තියෙනවා. Tag එකේ. What does that say? 3 liters per second. තප්පරයට වතුර ලීටර් 3ක් පම්ප කරන්න පුළුවන්. What is the use of this day? මොකද මේ data account වෙන්නේ? I have was what? Third one. Duration of irrigation. Duration. Irrigation interval නෙමෙයි. Duration. Duration of irrigation කියන්නේ මොකද්ද? The time period required to complete one irrigation. The time period required to complete one irrigation. එක ජල සම්පාදනයක් සම්පූර්ණ කරන්න ගත වන කාලය. How many hours? That means what? To an area for hectare chili land. Miris කොටුව හෙක්ටයාර් දශම වර්ග මීටර 4000ක එක සැරයක් තෙමන්න ඉරිගේට් කරන කොච්චර පැය ගණනක් යනවද? That is scheduling. For that you need what? ලීටර් 3ක් දාන්න තප්පරයක් යනවා. To apply 3 liters you need 1 second. And to apply the whole volume, how many seconds or hours are needed? Then airport transpiration rate of crop. Can you remember last time we discussed water losses, upward loss? ජලයේ හානිවීම අපි කතා කළා upward losses කියලා. මොනවද? Upward transpiration, respiration, evaporation, transpiration. Evaporation from soil surface. Transpiration through the plant body, from body. Saaking latin transpiration, solvent transpiration. As common we say, evapotranspiration. That is water removal from the crop. That is given 2 millimeters per day. Method mataka diyaganda. That's why I have bold. Evapotranspiration ET is always given in millimeters per day. Standard delay. Evapotranspiration is the water removal. That is given in millimeters per day. What is the necessity of that data? To calculate irrigation interval. Irrigation interval. You apply water to field capacity. How many days it takes cropping field takes to reach temporary waiting point? ඒ කියන්නේ මොකද්ද? allowable dispersal level. ශේෂ්ඨ දායකයන්ගේ වතුර ප්‍රමාණය 150ක් අඩු දවස් 30ක් යනවා. දවස් කීයක් යනවද? How many decline per day? That is 80 millimeters per day. Then capacity of the water pump. Finally, we are going to calculate the cost. You can see here. Total cost for irrigation for the season. 100 and samast period. That is an electric motor with the compare. So what is the cost? Electricity cost. How can we measure? By units. Within that means 1 kilowatt hour. So you should know what is irrigation interval. And that is to calculate how many hours. Then total cost for irrigation for whole 4 months. Mass hathari available. Here calculate. That is I can give here. Capacity of water pump. Here it is given in 1 horsepower. It still being used now by the government. But you know your electricity bill. That is coming watt hour meter, kilowatt hour meter. Kilowatt hour. Kilowatt එකක් පැයක් පාවිච්චි කරොත් විදුලි එකක් වැය වෙනවා. If you consume 1 kilowatt per hour, you have taken the 1 electricity. Okay, එක විදුලි එකක් වෙනවා. එකයි here. For that you need capacity of water pump. Then the duration of irrigation. 120 days. The chili poppies, they are in the field for 4 months, 120 days. Last one. Cost of electricity unit, I assume 30 rupees. That is the earlier price. Here. Now shall we see how to solve this problem? Number 1, I gave you these 5 parts you have solved. Make potash part uttara value. If you complete the answers for these 5, that is irrigation schedule. That is the report of irrigation for that crop for that season. Holiday crop schedule. Now, read this page yourself. I will give 2 minutes. Turak denna, 3 minutes maximum. Part by part, element by element, letter by letter, akuren akura kiyawana. If you have not read earlier, kali kiyawana nangi me sati purata. Now read letter by letter, word by word. Try your best to make understand. Otherwise, I will help you. This is very much important. Take a piece of paper on a calculate yourself. Get practice. Practice self. What we are going to calculate? Net depth of water requirement, gross depth of water requirement. Can you remember last time I gave one example? Biscuit tin or packet onto a gross weight can with the container with the wrapping Packet net weight can only the weight of viscous. Theoretically, you consume the viscous. Practically, you take whole. That is why net depth කියන්නේ theoretical water requirement එක. Gross depth කියන්නේ practical water requirement. That is net depth plus wastages. Now, you take a piece of paper, කොලයක් අරගන්න. කෙමීන් බාන්න මේක ලියන්න තේරෙනවා. විනාඩි දෙකක් තුනක් ගන්න. Take 2 minutes. Okay, now I will help you. Please check whether where do you have problem. Where ගැටලු තින්දෙන් බලා ගන්න. Number 1, net depth of water requirement. සුද්ධ ජල අවශ්‍යතාවය. What does that mean? Last time we discussed the water requirement, volume of water requirement to bring the soil moisture up to peak capacity from temporary melting point. තාවකාලික එක depletion level එකේ ඉඳලා ශේෂ ධාරිතාවට ගේන්න ඕන වතුර උසක් හැටියට. කොහොමද අපි කරන්නේ? What is the equation? Field capacity minus permanent unit මම විස්තර කරා. Maximum field capacity minimum permanent unit. එහෙනම් මේක මොකද? Available water. Field capacity minus permanent unit. In your problem, field capacity is 22%. Permanent melting point is 12%. And 22 minus 12 as a percentage, that is this part. Second one, management allowed depletion level. That means allowed depletion level. කළමනාකාරීත්වය ඉඩ දෙන පහළ යාමේ මට්ටම. Simply what is that? Temporary melting point. මේ කියන්නේ මොකක්ද? తాවකාලික මැලුම් අංකය. In the problem, it is given allowable moisture depletion level. How much? 50%. That is why 50 over 100. Then root zone depth. Only we apply root water up to root zone depth. We want to wet only the up to root zone. You should know what is the root zone depth in your problem. 0.2 meters. That means 20 centimeters. That's meter කියන්නේ 20 centimeter. 100 centimeters per meter. Last on bulk density. I told this we discuss. That is, that will you how much micropores are there to retain capillary water. A passe KC jade rando ganna kochchara sudra අවකාශ තියෙනවා. ඒක ඉන්ඩිකේට් කරන්නේ ඝනත්වය 1.2 grams per cubic centimeter. Now you can multiply all together. දැන් මාත් එක හදන්න. 22 minus 12 22 12 10 divide by 100. The විදනවා 100 0.1. Then 50 over 100 0.5. 100. Then root zone depth 20 centimeter. That has been given. Then bulk density given 1.2 grams per cubic centimeter. Then what is the answer? Then the answer sulu karanda calculate. 20 into 5.5. Vissa dasam pahin. Again vissa bagi 10. 10 into 0.1. The high dasam again. Again what? 1 into 1.2. Again 1.2. What is the unit? Centimeter. Usak kheti the network centimeter dekai. Ekan sam dekai. Then what does that answer indicate? May network requirement answer indicate karne මොකක්ද? You do irrigate 20 centimeter soil profile. Centimeter is usada soil profile leka. 500 පැති කරක් ඔබ තෙමනවා. ඔබ centimeter 20ක් උසට 5 පැති කරක් තෙමනවා. You are wetting soil profile up to 20 centimeter. Right? That is the soil, that is the root zone area. Then centimeter 20ක් වතුර දාන්න ඕන වෙන්නේ centimeter 1.2යි. For within 20 centimeter soil profile, only you need very low water volume. That is 1.2. 1.2. Give me 1 second. Then you can see what we are discussing. For within 20 centimeter soil profile, centimeter 20ක පස් පැතිකඩක තියෙන්නේ කොච්චරද micropores උසක් ඇටගතුන 1.2. ඔබ 1.2ක් උසට වතුර දැම්මොත් ඒක සෙන්ටිමීටර් 20ක පස් චට්ටුවක micropores හරහා යනවා. Then and 0.1 into 0.5, sorry, 20 into 0.5. 20.5 10 10 into 0.1 10.1 1 1 into 1.2 1.2. What is the answer? Centimeter. Then you may have a problem. What happened to this unit in the density? මේ ඝනත්වයේ ඒකකට මොකද වුනේ? ඝන සෙන්ටිමීටර් ග්‍රෑම් කියන මොකද වුනේ? ඇයි ඒක අපි ගණන් ගත්තේ නැත්තේ? This is given here. මේ මොකද අපි දිහා තියෙන්නේ? මම මේ බෝඩ් එකේ තියෙන එක පැහැදිලි කිරීම. This is the explanation. බලන්න. මෙන්න මේ ඉඩ මේ soil එක අපි පුරවන්නේ මොනවද? This soil profile macropause is filled by what? Water. Jale. What is the density of water? 1. Then බලන්න. D is equal M over V. D සමානයි M බෙදීම V. පොඩි කාර්ය කරනවා. D is what? Density ඝනත්වයේ සමානයි mass ස්කන්ධයේ බෙදීම පරිමාව. Density is equal mass over volume. ඝනත්වයේ සමානයි ස්කන්ධයේ බෙදීම පරිමාව. ඒකේ පරිමාව ස්කන්ධය කියන ඝනත්වය කියලා. The weight of one volume is called as density. Then the mass of one volume. Then in the water, what is the density? 1. මොන කියනද ජලයේ ඝනත්වය 1යි. ඒ කියන්නේ මොකද්ද? D is equal M over V කියන්නේ මොකද්ද? D is equal M 1 gram V 1 cubic centimeter. ජලය 1 cubic centimeter යක්. දිග පළල සෙන්ටිමීටර් තියෙන එක පරිමාව සමානයි. ඒකේ බර එනවා ග්‍රෑම් එකක්. එතකොට 1 බෙදීම 1 උත්තරේ 1යි. එහෙනම් D 1 is equal 1 over 1. එතකොට මොකද වෙන්නේ? යුනිට් නැතු වෙනවා. යුනිට් ඕනේ. දෙපැත්තම සමානයි. That is why we removed this. We did not take this unit. Okay. Finally, now this is net water requirement. ඇත්තටම මොන වතුර ප්‍රමාණය? يعني න්‍යායාත්මක මොන වතුර ප්‍රමාණය? Not practical, not practically. එහෙමනම් දැන් බලා ගන්න. Now we have calculate net water requirement. That is the what is the answer for what question? How much to be irrigated? කොච්චර දාන්නේ? දෙවෙනි එක. Gross depth of water requirement. මං කිව්වා. Biscuit is 500 gram, but packet is around 500 gram. From the market, you have to purchase whole 550 grams, but you consume only 500. Biscuit is the packet, but you have to purchase both. ඇත්තටම ගෙදර ගියන්නේ 500 පරක්. හැබැයි කන්නේ 500. ඒවයි තමයි. ඇත්තටම වතුර දාන්න ඕනේ. ඇක්චුअल කොච්චර දාන්නේ that is practical. With wastages. එමනම් බලන්න. Gross depth of water requirement දල ජල අවශ්‍යතාවය. අපි දැන් පැහැදිලි කළා. That is the practical water requirement with wastages. එහෙනම් මොකද වෙන්නේ? How to get gross depth of water requirement? That is net depth of water requirement divided by water application efficiency. දැන් මම කතා කරන්නේ. මොකද මෙතන ගාන කීයේ තියෙන්නේ? irrigation application කියන්නේ 50%. දැන් මම කිව්වා. දැන් මොකද කියන්නේ? එහෙමනම් 1.2 divide by 50%. cm per 9.5 බෙදලා කියන්නේ මොකද්ද? ඒක ප්‍රති විලෝමයෙන් වැඩි කරනවා. අනිත් පැත්ත හරවනවා වැඩි කරනවා. cm බෙදීම බලන්න 2යි. 2 වර්ගය මොකද අපි 2. 2 තමයි. Now you can see you need only 1.2 cm. That is the net water requirement. But 50% is the efficiency. Therefore, you have to double. Gross water requirement is double the net water requirement. දල ජල අවශ්‍යතාවය සුද්ධ ජල අවස්ථාවෙන් දෙගුණයක් වෙනවා. Then එබැවින් different irrigation methods are there. විවිධ ජල සම්පත් ක්‍රම තියෙනවා. මොනවද? අපි දැන් කතා කරමු පොඩ්ඩක් කිව්වා. අපි පස්සේ කතා කරනවා ඒක ඊළඟ ලෙක්චර් එකේදී. presentation එකේදී. If drip irrigation is used, what is the efficiency? 90%. Again, මොකද්ද? If you apply 100, 90 is absorbed. If you use sprinkler irrigation, 70%. එම්නම් අපි අහනවා if the NW are 1.2 centimeters like here in this program 50%, but if you apply same crop by drip irrigation you need only 1.33. Why? 1.2 divided by 90%. 1.2 බෙදනවා 190 වෙන. එච්චරයි. Sprinkler irrigation 70%. 1.2 divided by 70%. Answer is 1.7. Then our third part, duration of irrigation. කොච්චර කාලයක් අවශ්‍යද ජල සම්පාදනය කරන්න? විනාඩි දෙකක් දෙන්නම් හැමින් ඔහොම බලා ගන්න. පේලි 6-7 විනාඩියක් දෙන්නම්. එකපාරක් කියනවා. read once. එකපාරක් කියන්න. Okay. Now, the total is what we have to do. What we want to calculate. අපිට මොකද ගන්න කරුනේ? Duration of irrigation. ජල සම්පාදනය කරන ඕන කාලය. There are two factors are needed. Two data are needed for this. මේක ගන්න කරන දත්ත දෙකක් අවශ්‍යයි. මොකද්ද පළවෙනි එක? Total volume of water required to that field. එම ශේෂ්ත්‍රයේ ජලය කොච්චර පරිමාවක් ඕනේද? Second thing, duration. What is the pumping rate from the water source? වතුර පොම්පේ පම්ප් කරන වේගය කොච්චරද ෆීල්ඩ් එකට? discharge rate. These two are needed. Then first one, the total volume of water to be irrigated. What is volume? Length, width, and height. පරිමාව කියන්නේ දීඝ පළල උස වෙන සංඛ්‍යාවල මොකද්ද ශේෂ්ත්‍රඵලය කියන්නේ ඒරියා කියන්නේ දීඝ වැඩි කිරීම පළල පොඩි කාර්ය ගන්න හදනවනේ එහෙනම් area එක දීලා තියෙනවා කොච්චරද 0.4 hectares area එක දීලා වර්ග මීටර 4000යි square meters 4000 what is the depth we have calculated what that is gross depth of water requirement as a height we calculate 2.4 centimeters centimeter 2.4ක වතුර උසක් ඕනේ now you know height or depth is 2.4 centimeters we want to convert it into meters මොකද හේතුව area is given in meters ක්ෂේත්‍ර පරිධිය meter වලින් නම් ඔක්කොම හරවන්න meter වලට එහෙනම් we are converting 2. That's so we are converting 2.4 divided by 100 why 1 meter is having 100 centimeters එක meter centimeter 100ක් තියෙනවා නම් centimeter meter කරන්න 100 බෙදන්න that is why 2.4 divided by 100 now what is the answer 4000 into 2.4 divided by 100 the answer is 96 answer 96 96 what is the unit square meters into meters वर्ग मीटर වැඩි කිරීම meter ඝන meter cubic meters therefore the answer is 96 cubic meters but in your data the pumping rate is given in what is the unit liters per second දත්තවල දීලා තියෙන්නේ වතුර පොම්පේ විසර්ජන වේගය තප්පරයට ලීටර් 3යි 3 liters per second එහෙමනම් if that's so here 3 liters per second now what we have to do these 96 cubic meters you have to convert into liters that is why 1 cubic meter is equal 1 into 1 into 1 length is 1 meter width is 1 meter depth is 1 meter දිග උස පළල මීටර 100 කොටුවක් නම් that is called as cubic meter in such cube you have 1000 liters දැන් ඒකත් එක නම් එක වැඩි කිරීම 10 වැඩි කිරීම 10 වැඩි කිරීම 10 එවනම් මතක තියාගන්න cubic meter එකක් කියන්නේ 1000 liters එමනම් 96 cubic meters කියන්නේ 96000 liters now you know what is the total water volume per one season ඔබ දන්නවා එක සැරයක් වතුර දාන්න to irrigate once you need 96000 liters ඊට 96 then you are taking the second data discharge rate of water pump 3 liters per second එහෙමනම් now what you can summarize how can you develop the answer to irrigate to pump 3 liters you need a 1 second then 3 liters 1 second 96000 liters you need 1 second for 3 liters into 96,000 liters. Then what is the unit of answer? Second. Tappara gana kenne. Loku tappara gana. Apita amaru ini. The standard is what? Hours. Paya gana. 1 hour is equal 3600 seconds. පැයක් කියන්නේ තප්පර 3600 ඒ දන්නවනේ එහෙනම් we divided by 3600 what is the answer 8.88 hours පැය 8.8යි දැන් මොකද කරන්නේ you know time is not given in decimal values නේ කාලේ දශම ස්ථානෙ දෙන්නේ නැනේ what is the applied day කොහොමද බලන්න hours and minute පැය සහ විනාඩි then what do you do You have to keep this 8 as it is. 8 hours M 0.88. We convert into minutes. How can you convert? 1 hour means 60 minutes. If that's so, 0.88 multiplied by 60. What's the answer? 53 minutes. So far, we have calculated net depth of water, gross depth of water, and irrigation duration. Finally, what you can say, to complete one irrigation, you need 8 hours and 53 minutes. Extra jal sampadan about අවශ්‍යයි පැය 8යි විනාඩි 50. You have calculated the third answer also, duration of irrigation. Then we move to the next problem, irrigation interval. Very simple. මම කලින් විස්තර කරා. ජල සම්පාදන කාලාන්තරය, gap between two irrigations in days දවස්වලින්. මම කිව්වා වතුර ඉවත් වෙන්නේ මොකෙන්ද? ඊට transpiration. අපි ඇත්තටම දෙන්න වගේ මොකද්ද net water requirement? ගහට දෙන්නේ. අපි field area apply කරන gross water requirement. එහෙමනම් බලන්න. Irrigation interval. I that is equal net water requirement divided by 80. සරලව තේරෙනවනේ. net water requirement අපිට ආව කොච්චරද? 1.2 centimeters. හැබැයි ET දෙන එක මොකද්ද? ET is in millimeters per day. You can see in the data, always your transpiration is given standard is millimeters. Millimeters in me. If that's so, we have to convert centimeters into millimeters. 1 centimeter is having 10 millimeters. 1.2 into 10, 12. 12 millimeters net water requirement. What is the removal? ET, 2 millimeters per day. You divide 12 over 2, 6 millimeter goes out. Days remain 6 days. That means what? Today is Sunday. If you complete irrigation today, after 6 days, again next Saturday, you will supply water. Okay, the last part. Total cost for irrigation. Megat balaganda vinadi. Tani. Then I will explain. We are going to calculate the total cost for irrigation. Samastha pirive mulu viyadamu. For the whole season, mulu kannetamu. What is the duration? 120 days. Masa 4. Tirathina datte. මෙතන මධ්‍යන ප්‍රධාන සාරාංශය යටම තියෙනවා මොකද්ද? Pumping cost. Electricity cost for pumping water. කොහොමද අපි දෙන්නේ? Kilowatt ampere hours. One kilowatt hour mean 1 electricity unit. In your home, obey electric meter with meter kilowatt hours. How? if you consume 1 kilowatt for hour, you consume 180. Kilowatt එකක් පැයක් පාවිච්චි කරොත් අපේ විදුලිය එකකයි කියන්නේ. Kilowatt කියන්නේ මොකද්ද? Watt into 1000 meter kilometer වගේ. එහෙමනම් ඔබ දැනගන්න ඕනේ මොකද්ද? To calculate total cost, you should know what is the watt or kilowatt, then how many hours you operate. In the first part, we are calculating our part, hours. For that, first of all, you should know number of irrigations. From planting up to harvesting. पहले हिटोपु දැන් අස්සන්න යන මාස 4 දක්වාම කොච්චර වතුර දැම්මද? කොහොමද හොයන්නේ? Crop duration 120 days. Irrigation interval will calculate 6 days. 126 over 6 days going out. ඒ කියන්නේ මොකද්ද? දවස් 120ක් පුරාවට දවස් 6කට වතාවක් දානවා. Up to 120 days. Every 6 days you apply water. How many times you apply? What the answer? 120 divided by 6, 20. Visivatawa, 20 times you have to apply water. Now it is okay. That is number of times. But what do you need? Number of hours. Total pumping hours. How can you calculate? In this problem, we calculate irrigation duration 8.88 hours. Irrigation duration 8.88 hours or 8 hours and 15 minutes. Then for 20 times, total number of hours 8.88 into 20, 176 hours. That is hours. Then you can see. Now our part is okay. Pagana hari. Now you need kilowatt. How many kilowatts? Many method via that the capacity of pump is 1 horsepower. The other pump is that horsepower. We have converted into SI unit. Up SI unit to Harono, commodel. 1 horsepower is 75.75 kilowatt. How many gun? Pumping capacity. Pump capacity 1 horsepower. Horsepower is 746 watt here. අපි හරවන්නේ කිලෝමීටර් 60ක්ම. ඒ වගේ. එමනම් for our convenience we make it round. අපි මේක වටේනවා. How? 746 cc equals 750 approximately. That was in 750. That is what we need. Kilowatt divided by 1000. 750 750 divided by 1000. 0.75 kilowatt. Now all okay. Now you know kilowatt. Earlier you know hours. 170 hours. Then what is the answer? And a number of incidents can be kilowatt hours. 0.75 kilowatt into 176 hours. What is the answer? 0.75 into 176. Answer is 132. That is kilowatt hours. Kilowatt hour electricity. Then what you can say? For the whole season, you are consuming 130 units. ඔබ කන්නේ පුරාවටම විදුලිය එකක 132ක් පරිභෝජනය කරනවා. You consume 130 units electricity. Then what is the cost for electricity? In the problem, 1 unit 30 rupees. Then 130 to 3,960. That is the total cost. What does that say? For 4 months, mass 20 times pumping, you need around 4,000 rupees. That's the cost for irrigation. Now we have calculated within 1 hour back, I explained this problem very clearly. Then, this part we discussed last time. Irrigation requirement, needs, water balance. All we discussed last time. Water balance equation of Mukatagal. Okay, now we are moving next presentation. I have sent you the notes. Notes everything. Please make remember. You have the quiz. Make a quiz Wednesday 8 p.m. to 8:30 p.m. You can submit up to 9. Badada අටේ ඉඳන් 9 වෙනකන් තියෙන පැය භාගයක quiz එකක් තියෙනවා. For submission half an hour is given. Okay, then we are moving the method. මොකද කියලා තියෙනවද?
6 වෙනිදා සර් තියෙන quiz එක.
Wednesday කවුද දෙන්නේ? Yes, 6 Avinda. Now we are moving the next presentation. Can you see the new screen? All screen में play होता है. Share विलाद है. Micro irrigation system के लिए share विलाद है.
Yes sir.
Okay. Now can you remember where did we start? අපි කොහෙන්ද පටන් ගත්තේ? Irrigation scheduling. What did I say? There are 3 components. How much? Now we have calculated. That's the problem. Number 2, when we have calculated irrigation interval. Still you don't know the answer for third question. What was the question? How to be irrigated? What was the answer? Methods of irrigation. Last time I briefed Mama Ketian and today, next 2 hours, I am going to discuss them in detail. ඉතුරු පැය දෙකේදී මම විස්තරාත්මකව මේක කතා කරනවා. එහෙමනම් බලාගන්න methods of irrigation මම එදා කතා කළා. ප්‍රධාන ක්‍රම 2යි. ප්‍රධාන ක්‍රම 4යි. මොනවද? surface, subsurface, sprinkler and drip. එදා මම ඉවර කළේ කොහොමද? That can be categorized into 2 groups. Conventional and advanced. සාම්ප්‍රදායික සහ වැඩිදියුණු. සාම්ප්‍රදායික මොකක්ද? Surface and subsurface. Advanced, modern, sprinkler and drip. මෙන්න මේ දෙක අපි පොදුවේ කියනවා. වචන ලියා ගන්න micro irrigation system. In Sinhala, Sudra Jal Sampadana Paddhati. Sudra, small volume of water we apply. Therefore, please make clear, පැහැදිලි කරගන්න. Micro mean drip and sprinkler. बिंदु जल संपादन सह विष्णु जल संपादन. You can see here in left hand side, one patch side is sprinkler irrigation. In a greenhouse, that is misting or fogging. Fog එක හදනවා. Mist එක හදනවා. Actually, for what? To maintain RH and to control temperature. Actually, temperature. That is sprinkler. In your right hand side, drip irrigation. A field drip irrigation. Okay. Then, what do you mean by micro irrigation system? What is the micro irrigation system? Applied measured quantity of water. ඒකයි advance කියන්නේ. අපි කලින් වතුර මයින්නවා. slowly කෙමින් වතුර දාන්නේ. and directly above or below the soil surface. එක්ක පොළොව උඩට දානවා. එහෙම නැත්නම් පොළොව පොඩ යටින් දානවා. in this pot මේ pot එක මතකද? surface depth. You can see the dripper. මේ ලාකොල පාටේ තියෙන light green color. That is the dripper emitter. Then we are going to discuss what are the types of micro system. शुद्ध जल संपादन पद्धति वर्ग मनोवाद. Number 1, surface depth. A drip irrigation system. The system is over the soil surface. Emitters. Emitter can water releasing emitter. This is the emitter. Emitter अभी dripper गिराती है. Emitters and lateral, methane lateral line, micro drip star lateral line, methane lateral line. Laid on the soil surface. Followed in paint. Laid atulladil. Then what are the advantages? Not vast. Convenient is only garden high garden. It is stressing and it over. High garden. Place it. Convenient inspection. You can check. Right? You can see water coming out. Any blockage, water does not come, then you can check. That is called as inspection. Clean of emitters, convenient can pass, easy. Clean. You can remove this emitter, open. You can open and clean. Possibility of taking wetting pattern. This is the photo field. You can see the wetting pattern, vertical or horizontal. Last one, measuring individual discharging rate. You can keep a container and measure by the mind. Second method, subsurface drip. Here I have mentioned earlier method. Surface drip, you can see here. Once you have surface drip, what is the main problem? Damage by animals or ourselves. Then we butterfly over the animals, products, mio, dog, wallow, occupy in town. All sorts of animals do damage. They do bite. Happen. Then ourselves, we can't operate tractors for weeding. Weed current by water over the. We can't do intercropping. Can't be. Limitations of harvesting. Hammer the am get followed by the. But subsurface, you can see water supplies flowing below soil surface. Follow yakin yaman. Then what are the advantages? As I just mentioned earlier, you can control animal and other sort of damages. As well as now, so you can't see water that is underneath. Then follow the net. Then what you can say? You can reduce the evaporation. As I just mentioned earlier, very little interference. Balakam Hariadu, Munada, cultivation, intercropping, miscropping, Munavan the bear, then make fully advertising. And cultural practices, all sort of practices, with control wildlife application, Muhammad and particular. Subsurface is very good. Why you can't see what? Third one, bubbler. So, Bob, please understand. Surface drip, subsurface drip. Now the irrigation is over. What is our topic? Micro irrigation. Is sprinkler system, sir. Bubbler, very small stream is coming out. The discharge rate is little higher than surface drip or subsurface drip. But bubblers කියන්නේ lateral line එකේම සිදුරක් වගේ විලා දිනවා. එතනින් වතුර මලක් වගේ වෙනවා. What is more limited දාන්නේ? Bubbler. Make sure that is a sprinkler system. Why water is spread over area. Whatever material. Advantages, these are the advantages. Then microjet. That was a spray water. It can release much water, greater discharge rate. And coverage, more coverage, great coverage than different bubbles. ලොකු ප්‍රදේශයක් තිත් කරන්න පුළුවන්. Next method, micro mini sprinklers. As the name suggests, sprinkler, signaling visuru. Water is spread into air. Why would it ask them now? Allowed to fall on the ground as rainfall. Normally at 1 meter height. Then microjet. Somewhat large, drip-head. Okay, jet end yellow. Where? Microjet means it can cover a large area. In the case of microjet, you can see, as you said, what is applied as a spray. It can cover a large area than bubbler. That's very much important. Then we are moving micro mini sprinkler. Or then we have a compound micro or mini sprinkler. 2D sprinkler. From the ground level 1 meter height. Within diameter is 4 meters. 4 meter diameter. Here you can see discharge rate is higher than bubbler for microjet. Next method, microjet. Next method, misting or fogging. Man kalimba penny misting and fogging mulama kaya rupiah. This is misting or fogging. Make a mistake. Fogging. Water, you can see here, application water in the form of very fine spray. Ita chudi dara under very high pressure. Very high pressure. What's the purpose? To create humidity in the air. Sape sartai very grand. Using polytunnel, greenhouse, haritagar, polythene viewer to control humidity and temperature. Sape sartai very good. Increase RH cannot happen. Temperature comes down. Usnatte aduvenava RH very good. Now greenhouse se प्रधान कार्य करते हैं. You want to reduce the temperature. But you know, usnatte adugan. For that what you do? You increase RH. To increase RH, you make mist. Need mahadano. Fog. Very high pressure. You need very high pressure. Last one. Pop-up spin. Pop-up can pop-up. Pop-up. Pop-up spin in playground, round, they want to keep wet. You can't have lateral lines, rise and heads and the back, pattern in a more gallery. Sprinkler system mega. Follow keep my Matuldan. Once it is not yours, once the clear space is not work. You can't see bubbles pop up. You can't see pop up. Why? It is a deep tape. Black tape by wind. Right again. It's been the head they shoot in that as a bubble. Body not there. What happened? You can see sprinklers are installed just below the ground level. High color. Once you switch on, get activated the pressure of and comes up from the ground level. Motor DAPM pressure pop-up sprinkler comes up. Spray water around. You shut off that retain the original place. That is why when the system is shut off, sprinklers automatically go back to the original person. Generally used for guards and loan, Mankiwa. Tanakal Pitani can loan, guard can pity, playground, and buy them. That is only for types of microirrigation system. Now I am going to discuss with you one part. How to compare drip, sprinkler, and flood. Now we are going to compare irrigation methods. What are they? What I'm going to discuss? You can see moisture content, X, Y-axis. X-axis number of days time. What we really discuss here, how to maintain soil surface wet. Now you can see one by one. Y-axis moisture content can follow තෙත්තෙන ප්‍රමාණය. Soil moisture level. මොනවාද? Saturation, capillary, and permanent yielding point, and temperature. then දන්නවනේ. How different irrigation methods behave? කොහොමද විවිධ ජල සම්ප්‍රදායම හැසිරෙන්නේ? Number 1 drip at the top. Why? Every day, throughout the day, you supply water. Drip irrigated land, you maintain continuous net field capacity. You don't have irrigation interval. Every day you apply water. You not have. Low cost is the model. Thereafter, you can see second one is sprinkler irrigation. Up to 70%. What they do? Every 1.5 day normally you supply water. There's a little irrigation interval. In the surface methods, what happens? They wait up to temporary wilting point. Then they have an irrigation interval. How many days here? 2 days. You can see here, every 2 days you supply water. Again comes to field capacity, again going down. Then we are moving. What are the benefits of drip irrigation? මම මෙයා කරන්නේ වල බලා ගන්න නෝට් එක මම වල තියෙනවා. මොනවද drip irrigation වල වාසි? Number 1, we discuss water efficiency up to 90%. Then you are keeping always water at field capacity. Then what happens? Increase plant begin and go field. Sakal product water stress එකක් නැහැ. No water stress. The required volume is always available. Therefore, increase plant bigger දිරිය වැඩි වෙනවා. Strength and the yield. Labor saving. You can save labor. Then poor quality water you can use by filtering. Use in hilly areas, even the slope land, no need to level. You can put laterals. Then reduce weed growth. Why you wet only the root zone? What is the manne? Saving fertilizer, you can mix fertilizer and apply. Less pest and disease. Why? You only wet the plant origin, base, not the surrounding. Irrigation appear rate can be adjusted soil type. Loose soil and the waking with the sandy soil and the himin down. What appear rate? Higher rate for loose soil sandy, lower rate for normal other method. Yes. Then water and fertilizer can be applied in form. You can mix fertilizer with irrigation water. Again, irrigation here. Then what are the limitations? Decreasing the සීමාකාරී සාධක. Number 1, the most prominent one, මම exam එකේ what is the main problem of drip irrigation? High initial cost. High initial cost. The basic cost. For instance, for at present, 1 acre coconut land, that means 0.4 hectare, you need more than 100,000. But you can recover within maximum 2 years or 2.5 years with the profit even. But high cost is the main problem. Next one, high power requirement, especially and sprinkler. You need pumps should be operated. Plug-in of parameters. You can see here, plug-in. plug-in කියන්නේ blocks emitters by inerts. Cloth is presently saline material in water. Lavada, jadeti lavada, problem. Then we have to wash them, suddha cleaning, using phosphoric acid through the line. Next one, damage chances, products and other animals, Mio, Ballo, you have a field operation can't be applied but to do. Then, what are the other limitations? Short lifespan, all are plastic, LDP. Very carefully, you have to use this one. Short lifespan, maximum 7-10 years. Salt accumulation, salt can level. Why? If your irrigation water is with saline material, calcium, magnesium, what happens? If you apply water to the crop, due to salinity, water comes out from the crop. That's the main problem. Therefore, you apply much water, leaking requirement. As periphery of the road stone, in the rainy season, they come some. Last one, restricted development of roads. Emitter what did you do like Kavilo? Then we are going to discuss. අපි කතා කළා මයික්‍රෝ ඉරිගේෂන් වල ගොඩක්. ඒක කතා කළා සර්ෆස් ඩ්‍රිප් කියලා. සර්ෆස් ඩ්‍රිප් අපි ආපහු දෙකට බෙදනවා. මොනවද? Inline drip, online drip. Inline dipper surface inside the inline drip system of a dipper pin only lateral you can see. Inline system अपने कैंपस से बैटरी තියෙනවා. one day बैटरी ලැක් තියෙනවා. irrigation ඔක්කොම අපි කරනවා. මේ කරන ඔක්කොම අද කරන ලෙක්චරේ ඔක්කොම පැට්ටිය කරනවා. Then dipper surface inside the lateral in the battery. You can't see emitters. Only you can see the hole. Constant spacing. Come further in 10 centimeter, 20, 30, 40, 50, 75, 1 meter, 1.5 meters. According to the crop spacing, you can see the required kill line. Normally low cost than online. For what it is being used? Close growing crops. For instance, vegetables. Then online. Dipper surface above that. Elliot high karne or fenwall. Surface dipper is very particular. Cost take a very high cost. What is the usage? Long or high space crop, monother, white space crop. Plantation, coconut, horticulture, mango, banana. So those are the types of drip irrigation. Inline, online, that's all. Now what we discuss micro irrigation systems and types of irrigation drip system. අපි දෙවෙනි ප්‍රසන්ටේෂන් එක මොකද කළේ? ශුද්ධ ජල සම්පාදන පද්ධතිය අපි හතම විස්තර කළා. බිඳු ජල සම්පාදනයේ ක්‍රම දෙක විස්තර කළා. Okay, that is methods of irrigation. Now we are moving one more presentation. I have sent you the note. That is drip irrigation in detail. Can you see the new screen? Then pay no the screen irrigation here.
Yes.
Okay. Now you can take United with the 40 break tag and relax it. Stand up and move and here sit. What we are going to discuss in detail the period system, field layout. Why I am taking this presentation? This is our practical once you come to the university. ඔබ කැම්පස් එකට ආවට පස්සේ මේ ප්‍රැක්ටිකල් එක මෙහෙම දකිනවා. මේ සිස්ටම් එක මෙහෙම දකිනවා. That is irrigation practical. වාර්තින සෙෂන් එක. ගෲප් 5කට කරලා. ගෲප් 4කට කරලා. Therefore විනාඩි 2ක් වගේ පොඩි බ්‍රේක් එකක් ගන්න. මේ මම නෝට් එකේ වෙලා තියෙන්නේ. බලා ගන්න මොකද්ද ඩිෆරෙන්ස් කියන්නේ මොකද්ද? But this is the field layout. අපේ field එකේ තියෙනවා. These are the components. Pressure gauge, non-return valve, air valve, filters, main line, sub-main line, and these are our students are working with system. They are working installation. So these are the systems in the university. You can see they are working. So this is our field. These are the systems in our university. You should know how to, what we are doing with irrigation. This is the field. That's the way. Therefore, we are going to discuss the practical component of irrigation. Okay. We are going to discuss the components of drip irrigation, okay, in detail. Number one, first of all, you should know what is drip irrigation. In drip irrigation, as I mentioned earlier, we apply water frequently. අපි නිතරම වතුර දානවා. Every day. Then how much? The required and measured quantity. අවශ්‍ය ප්‍රමාණය මැනලා. Sometimes with fertilizer. පොඩක් තරක දාන්න පුළුවන්. How we have applied? Discrete drops. Discrete කැඩිච්ච බිඳු one by one. Continuous drops. එක දිගට බිඳු වැටෙනවා. Tiny streams සියුම් ධාරාවක්. Fine spray කුඩා ධාරාවක්. වැස්සෙන් දාන්න පුළුවන්. ඕන විදියට. How can we apply water? Through emitters. මේ තියෙන emitter එකක්. Online emitter එකක් මේ තියෙන්නේ. Inline emitter you can't see. That is in the lateral line. So this is you can see water emit. That is in the piping network. What is the advantage? Minimize water losses. How? You control deep percolation. Now you know what is deep percolation. No runoff, no evaporation. Why? You directly apply water to the road soil. Then, once you come to university for BSc degree, we are going to discuss this part. What are the design factors of preparation? How to design? Design කරන කතා කරනවා in detail. MSc එක in detail කතා කරනවා කොහොමද mathematically system එක layout කරන්න කියලා. Plan එකත් එක්කලා. What are factors? The land and soil type, water source, their capacity, recharge rate, what sort of the crop water requirement, climatic condition for your transpiration, and capital and the knowledge. These factors in detail. Next, this is the field layout. Major field layout. It is in our university. What are the components? One by one, very quickly. This is the pumping part. Water source, deep well or normal well. There is a pressure gauge here to read the operating pressure. Then there's a non-return valve. Then air valve. These are set of filters to clean water. Then there's another screen filter, other filters. Then fertigation unit and the main line. Submain and laterals are there. Now we can see one by one. Number one, deep well. This is the water source. Make Gabulida. Or either open well. Whatever. Then pressure gauge. The system is having pressure gauges at different places. At the very beginning, then different components, particulars and units and everything. Why? You should know the operating pressure. Then non-return valve. Valve, kapatia. Non-return valve. Return means only forward, no backward. From the pump to the field. Not from the field to the pump. But no. Why the system is operating on water moving. But at once you shut off, backward, then what happens? With soil particle. If they come to the pump will get damaged. If very pump damage, no backward movement. Prevent damage of pump. Then air valve. Sometimes air may enter into the system. Then you can't start the system. Actually, what it up, while you off, shut off the system. Then not happen. You have remove air. Domestic pumps, you can see same problem. But here, large system, therefore, automatically there is a valve, release air at start. Then filters are there, different types of filters. Gravel filter, gravel can metal, gravel, sand, may accommodate filter. I think this one. Media filter, gravel filter to purify water. This is this filter. Number of this size or temperature you can touch, get knowledge. So these three filters are there in the university. Screen filter, you can open and see the screen. This set memory. Media filter. Next on main line. From the filters, you can see the main line in the field. That is buried. Subsurface. PVC or LDP. HDP. PVC high density polyethylene. Submain, from the main line, some branches, submain. Then laterals, black color, flexible ones. In Sri Lanka, normally 12, 16, and 20 millimeters diameters are there. Lanka commonly diameter 12, 16, 20. They are low density polyethylene or linear low density. They are black color. To avoid algae growth, natnang kalupaning haladin, natnang make it algae hedinama. Then the system block and from the high cardin. This is submain line. This is the lateral. Here are using a connector called as grommet. Take off grommet can what seal it. You can see temperature of the high system. You can see this is the submain line. First of all, they make a hole, punch a hole. Then we are taking, this is plastic part take off. This is the water ring, water seal, grommet. So they fixed like here. And finally, after installation. Then these are the punches used to install drippers to the lateral line. You can see here. These are emitters. There are two types, NPC, PC. You have a degree in detail. NPC, non-pressure compensate. Pinne yamane karano haki. Here PC, pressure compensate. What does that mean? In the non-pressure compensate, system pressure comes down, water discharge comes down. System pressure aduino. But pressure compensate there is, you can see white color filter here. When this auto adjust they auto adjust the water outlet hole. So that's try to maintain the discharge. Even pressure decline. End cap, line end cap to close the line. Then I'm going to move new part. The gravity predictive system. There are two types of systems. Pump driven, gravity predictive. Pump driven can look system. Water has to move far away. Therefore, pressure is needed, much pressure provided by the pump. Small home gardens. What do you want to do? No need to operate the pump. You can use this type of overhead tank, like your house, at different heights you can see that. In the university, we are having this testing system, small table. What is the height? Only 0.63 meters. Centimeter hat to nai. Here, you can see here 4 feet. 8 feet. Standard. You can see these systems. We operate and we calculate the discharge and the command in area we calculate. Gravity pet, we pump water to this tank. There is a gravitational force. Why it is somewhat over the soil surface? Then there is a gravitational force. We use that power to send water. Gravitational force. That is called a gravity pet. Once the tank is higher, you can go water furthermore. Today and then what we have again, why? There's a high pressure. Now you can see how to prepare the submain line. And before that, in the gravity pet system, you can see two main parts are there. Head control unit and field layout. Head control unit head control unit. You can see here. Onema spin dip. You have a head control unit. What does that mean? Up to the field, water tank, ball valve, here, filters, may come up again, here. From the water source, pressure gauge, non-return valve, air valve, filters, main line. This is head control. This is the field. This is field layout. What is the difference between split and dip? Same head control unit in the field. This system drippers are there. Sprinkler system sprinklers are there. That's all. Now you can see. That is the difference. Overhead tanks, Well, filters, main and sub-main, those are head control. In the field, laterals and emitters, that is on the field layout. In the field layout, always only emitter in the sprinklers in the sprinkler system. Now you can see here. This is the way. Now you can see how to prepare sub-main line. This is our practicals. They are prepared installation of the system install කරන්න. What they do? They are using pegs for what? To level. They level करना. Lateral lines. We want to measure the discharge. You can see here. Now they are leveling. This is the pressure gauge. This is the ball valve. Either shut off or on. Then these are the containers. For what? Collect water. The tanks you hardly see here. I think maybe tanky. This line goes hundreds of meters. Every 5 meters, they collect the discharge for unit time. Discharge. What happened? The discharge gradually comes down. And then the discharge why? Pressure decline. Pressure in the dip system, what they do? These are the tanks. Number one, this is our university. 1, 2, 3 at different heights. These are the water outlets. Bowl well. This is the lowest one. Then what do they? This is the emitters. They have picks. Then these are the lines. What they do? From this tank, they measure water as I just mentioned earlier, every 5 meters. Then what is the rule? Any lateral line, any lateral line, the first emitter, and the last emitter, only there should be preferable range 10%. Flow variation. මේ line එකක පළමු emitter එන වතුර ප්‍රමාණය 10ක් විතර අඩුවෙන් දෙන්නේ. එතෙන් අපි නවත්තනවා. එහෙනම් 90ක්ම ලැබෙන්න ඕනේ. මෙතන ලීටර යයිනම් පැයකට එතන මිලිලීටර් 900ක් ඉන්නේ. ඒ කියන්නේ 10% decline. ඊට පස්සේ මේ lateral වහනවා. නැත්නම් ගස් වල වතුර මාරු. uniform නැහැ. අන්න ඒක තමයි මයින්නේ. අපි ඒකට කියනවා maximum lateral length. ඔයාලා ඩිග්‍රී දාපුවම මේ අපි ගණන් හදනවා. MS में आपको सामने पीसीस वाली डिजाइन करना irrigation. That is called as irrigation engineer. Okay, that is the end. Now we are moving to our last presentation. That is conventional irrigation methods. Can you see the new screen? Screen irrigation methods here?
Yes, sir.
Okay. Now, so far we discuss what we are actually discussing the methods of irrigation. That is for what? How to be irrigated. Then earlier we discussed micro irrigation methods, replenishment. Next we discuss drip irrigation in detail, practical field layout. Finally, now we are discussing conventional irrigation methods. Man, last time just brief. Man, today I am going to discuss them in detail. the same as last week. What is here? Irrigation methods. You can see. Earlier we discussed blue color one, drip and sprinkle, advanced, as micro irrigation. Now these are the red color conventional irrigation. Surface, we discussed there last week, brief, border irrigation, serial sampadane, check basin, basin jal sampadane, ridge and furrow, Elisa ridge sampadane. Now we can see surface irrigation methods. Multiple jal sampadane. What is the difference? We apply water, we convey water over the soil surface. Follow drip and sprinkler through piping network. Drip sprinkler here over the soil surface. Now, what are the methods? Border, check basin, ridge and furrow. You can see this is the water is conveyed over the soil surface. You can see there. Then cut off. Now what happened to the wetting pattern? Please observe hadi balagan. Wetting pattern nega. What is the problem there? Can you see the problem? Here we observe. What is the problem? In irrigation, what is the rule? We have to wet only up to root zone. But what has happened? In the earlier part, very high deep population, very high wetting depth. These are the wastages, making a harm. Then, in the border irrigation, you can see this is the water source. These are the borders. These are the ridges. You know, you wet one ridge at a time. Open that one. Now you can see wetting. Complete. You cut off. Open the second one. Now wetting. That is how border irrigation is practiced. Maybe border irrigation practice can be. Maybe I have to then water is applied soil surface. Border irrigation. Channel located in the upper edge. Number of long parallel strips borders separated by low ridges. What are the problems? You can see here. Normally, at the time of irrigation, this is the water ponding. But if you supply higher rate, then what happens? Overtopping, overtopping. This is not good. You can see here, what is the problem? Now, please see this one. You see the water source. Imagine water source. This is the field. Imagine field. There is a little slope. What is slope? Now what happened? Once you open this inlet, now water goes along the border from starting up to the end. When the rule please keep remember, you don't keep open the inlet until water comes to reach to the end. May inlet take only you allow 2/3. හිතන්න මේක meter 30යි කියලා. Assume 30 meters. You open this inlet. Then water enter. Out of 30, once this water plant, Kerala, Isra Kerala, reach to the 20 meters, meter bisata yanakodama, you cut off this line. Vahana. Then what happens? Water that has entered to that 2/3 is enough to wet, enough for wetting last 1/3. In නැත්නම් වතුර වැඩි වෙනවා. පැහැදිලිද? තීරුවක දිගෙන් 3න් 2ක් වතුර යවට අපි වහනවා. ආපු වතුර ටික ඇති ඉතුරු වෙන එක තමයි. ඒ නැත්නම් මොකද වෙන්නේ? මේ බලන්න. Now you open. Please see animation. Now you have cut off. Cut off पर होता ही नहीं. Kerala के पास से. Did you see? Now what happened? Finally, number. You can see last 1/3 water ponding there. Finally, what happened? Did you see? Deep population. That is, you can read. Before reaching the water pond at the tail end, crowd and cutting. Water stream should be cut off. Cut off करना. Come there. Usually at the start of last 1/3 border. मैं अंतिम तुलने पटंग कानून cut off करना. If not, they would create excess irrigation at the tail end. Tail end crowd excess irrigation. मैं कहता board irrigation का practical point है मांगो admit कर दी. Then you can, I have sent the note, read करेगा अंदर, क्यों अंदर? What are the crops in Sri Lanka? Normally, these foreign countries wheat, barley and something. Sri Lanka, you can see other crops, field crops, sometimes paddy also in up country. This is how to design borders. Lanka up country and mid country में आती है. कमुकनी पास दिगर इतने खड़गा ना बैठते. गंपर ना भी बैठते. You can see. How to design contour borders? Balagan. This is the original land, slope, maintain bound. What is the intention? Make it into borders. Maintain borders of Harona. Kapano. After cutting, these are the steps. Borders. Now how to irrigate? This is the upper end. This is the lower end. What do you do? Slope is here. Maintain the bound. These are the steps. Maintain the paddy wagi. Memang helmatin. Ekapating waktu supply करना. Palya podi bound में better देना. Uniform gradient. Excess water correct to the drainage canal. Paddy पूरा बात. You can see. Please see how to do irrigate. Okay. Then this you can read. Advantage, this you can read. Huh? Then the next method, furrow irrigation. There are 3 methods: border, furrow, and basic. Furrow irrigation means you can see, as I mentioned, Sri Lanka in the dry zone. Border irrigation mid country up country. Border irrigation medrata slope land wala. Medrata kandurata. Hilly areas. Furrow irrigation lowland. Pahat bima koide. low කාන්ති dry zone and intermediate zone. පහත් ප්‍රදේශවල low කාන්ති පහත රට dry and intermediate zone. What is the situation? In the Maha season, Maas Kanne, they have enough food. What they do? They do paddy cultivation. What is the method? Basin irrigation. In the other season, they don't have enough food. So what they do? They have to grow some farmers, they grow field crops. Say maize, badenu, onion, lonu, banana, kesil, and so on. Banana permanent, and field crops, seasonal. Beetroot, and so on. Chili, miris, ever. What they do? In the other season, they can't use basin irrigation. Basin irrigation you can't go use basin irrigation for vegetables, field crops. What they do? You have to make raised beds for furrows, ridges. What you have to do? You have to make the land uneven like this way, ridge and furrow, ridge and furrow. Why? Furrow is used to divert. You can see furrow. You can see here. Furrow is used to divert water. Crop is in the ridge. Vatiye boge tina aliye tamai watura harawan. Metin hai balagai. This is a supply canal. Furrow ridge. So you can see. Okay, then once you divert water along the furrow, vertical movement of water, horizontal movement of actually there should be more horizontal movement. Otherwise, this crop can't receive water. That is why sandy soil, valley pasap is not suitable. Sandy soil is not suitable for furrow irrigation. We will discuss that later. Furrow irrigation, you can see here. Crops grown in row crops, vegetables, except sandy soil. Now you can see what is the reason. How does the soil type affect the size shape of the furrow? Loose soil, hard soil. Loose can loam soil, sandy soil. Clay soil can hard medipasa. What's the difference? Loose soil, vertical movement very high. Clay soil, very low vertical movement, very low infiltration rate. Number this is the on a same size furrow. But if you just observe the wetting pattern. Did you observe? In the loose soil, elliptical wetting zone. Why? Very quickly water goes down. In the sandy soil, very slow. That is why circular, even some part remain in the furrow. Then how can you adjust? You can adjust the shape of the furrow. You can see here what you can do. Did you observe? To control the elliptical water movement, you reduce the width, narrow, but you need to divert same water volume. While you are narrowing, to divert the same water, you should make it deep. Therefore, narrow and deep. What is the advantage to minimize water loss through deep water. Now the just opposite of this one in the clay soil. What you have to do? You observe. Okay. What you have to do? You make it white. For what? Absorb greater amount of water. Large surface area very no. Then you can increase in filter rate. For that, you make it wide. But same water volume, so shallow, no. So that is how soil type affect on farm. Then I am going to discuss, as I mentioned earlier again, why sandy soil is not suitable for irrigation. Why furrow irrigation is not suitable for sandy soil? Lateral movement is less than bottom. Make an elliptical unirrigated land. Unirrigated land. Therefore, sandy soil is not suitable for furrow irrigation. Advantage balaganda. Then we are coming to the last method, check basin. It can kumuru. In the Maha season, mostly we are doing. What we are doing? This is the paddy fields. Check basin. Check can hotwa. Basin can be sama. What it out? What a color? What we do? Field is divided into small areas. Field is within our world. Nearly level. Pulvantara mattam kar level. Bunds or ridges. What is the nearby dina kamidala? Mokada basin hadala to form basin. What you do? Basins are filled with water. You have puruna water up to decide depth. Water is retained. Kumura water purvadina until infiltration. Then depth of water is maintained. You can see here. I discussed last time. We discussed last time. From a reservoir, Mangati Kalavel, as an example, main canal, either left or right bank, Wamuru Dapunur, then branch canal, Sa Kalava, then D canal, distributor canal, finally F canal, field canal. Make in the D canal. Farm organizations are controlled. These are the field canal, small 10 or 20 fields. Now you can see how to divert water. Supply canal receive water, then enter to the field canal, then laterally movement within the individual paddy. What is the method? For a season, for land preparation, they either Department of Irrigation or Mahavali. Samhara Pati Mahavali Daiti, Samhareva, IT Irrigation Department. For example, Rajangan Irrigation Department. Kalaya Mahavali. Likewise. What they do for basin irrigation? They supply 10 shifts per season. 8 to 10 shifts. What is a shift? 3-day water issue with 7-day cut-off. Dawas tunak denawa hatak wan. 8 shift. Normally 8 shifts after establishment, 2 shifts before land preparation. Bin pilekanda mor dekak denawa pala vaputuwata passe irrigation 8 shifts up to maturity. But practically all paddy is grown in basin. Lankavi, Prayogo, Vivaga, one basin irrigation. They can conserve rain water. වැහි වතුරත් පාවිච්චි කරන්න පුළුවන්. Then finally we have come to the end. Subsurface irrigation. In Sri Lanka, you can't commonly find but බහුලව හම් වෙන්නේ. What is subsurface? In the Middle East, desert areas, මැද පෙරදිග, කාන්තාර පෙරදිග, hot area වල. In the surface method, what they do, they want to control evaporation. උන්ට වෙනවා වාෂ්පීකරණය පාලනය කරන්න. By hot sun, what they do? Two methods. They use, you can see, what they do, you can see open ditches, very deep open ditches. ඉතා ගැඹුරෙන් එළවල් හදනවා. Very narrow and very deep. What is the condition? Very small surface area. ගැඹුර වැඩි කරනවා උඩ අඩු කරනවා. එතකොට less chance for evaporation. or piping network. එනනම් බට වලින් ගින්න පොළොවේ යනවා. Crops are irrigated, making the water table not over the surface but below the soil. පොළොව යටින් තමයි water table එක තියාගන්නේ. That is done normally in Sri Lanka. Subsurface drip irrigation for coconut. දැන් ලංකාවේ පොළොව ගන්න එක. බලන්න ඩිග්‍රී කාල්පසෙන් කතා කරනවා සෙන්ටිමීටර් 50ක් යයි. surface දැන් කරන්නේ අඩුයි. No evaporation, no weed problem, nothing. Uneven subsurface scale. Okay, now we have finished whole syllabus. What I want to discuss? What I discussed last time, I defined irrigation. Why water is important in agriculture? Balaganna. It was what is the importance of irrigation? ගොඩක් අපි කතා product to product protect to ඔක්කොම කතා කරා. ඊට පස්සේ කතා කළා what are the types of soil water? බලා ගන්න ඒවා. Capillary hydroscopic gravitation, soil moisture constant, saturation, pH capacity, temporary melting point, permanent melting point. ඒ ටික ඊට මම කතා කළා water losses, downward infiltration, depercolation, seepage, horizontal runoff, upward evaporation, transpiration. It was මම කතා කළා field water balance, gains minus losses, keep it positive. Gains irrigation, rainfall, losses runoff, drainage, evaporation, transpiration is equal soil water balance, plant water balance. Always you have to keep it positive. To keep it positive, what you have to do? If not enough rainfall, you have to supply water irrigation by irrigation. However, you have to keep the soil wet. That is field water balance. Then we discuss what is irrigation scheduling. We have to answer 3 questions. We discuss how much net depth of irrigation, gross depth of irrigation. Gross is wet, net with wastages. We calculate the problem. Ganak hadua. Irrigation interval, time gap between 2 irrigations. That is dependent on your transpiration. මතක තියාගන්න irrigation interval always we divide net water requirement divided by your transpiration. ගහේ තියෙන වතුරයි බා net water. හැබැයි ඉතුරු වලට ගන්න gross water. ගණන් හදන්න. මොකද ඒක practical පැත්ත. ඒක හොඳ බලා ගන්න. Next, we discuss irrigation duration, then total cost of irrigation. How to be irrigated, methods of irrigation. There are 2 methods, conventional and advanced. Advanced, micro irrigation. 2 parts, drip and sprinkler. We discuss what are the 7 types of micro system. Then we discuss in practically field layout of a different system, what are the components? Finally, we came to conventional water plane methods. They are surface, 3 methods, border, basin, ridge and power. and at last subtract. Then it is finished. You will have your quiz on next Wednesday, May Sati, from 8 to 8:30. Whole submission period half an hour up to 9. LMS will be open 8 to 9 p.m. That's only. Thank you very much. After the exam, we will meet in the degree. Okay. Thank you very much. Now please ask from yourself, Obe Mahanna. Last Sunday evening, today evening, before sitting last Sunday, now after standing next this Sunday, did you got something new in irrigation? ගිය ඉරිදා වාඩි වෙන්න කලින් අද ඉරිදා වාඩි නැගිටින්න කලින් තිබිච්ච ජල සම්පත් දැනුම යමක් අලුතින් ගත්තද? That is very much important. Okay. Thank you very much.